Welcome everyone to Wednesday Night at the Lab. I'm Tom Zinnon. I work at the UW-Madison Biotechnology Center. I also work for the Division of Extension Wisconsin 4-H. And on behalf of those folks and our other co-organizers, PBS Wisconsin, the Wisconsin Alumni Association, and the UW-Madison Science Alliance, thanks again for coming to Wednesday Night at the Lab. We do this every Wednesday night by Zoom, 50 times a year. Tonight, it's my pleasure to introduce to you Titus Seilheimer. He's a fisheries biologist and fisheries specialist with the University of Wisconsin Sea Grant. He's stationed in Manitowoc. He was born in Ladysmith, Wisconsin, and went to high school at New Auburn. And then he went to Lawrence University in Appleton to study biology. He moved to Ontario to McMaster University to get his PhD in biology, and then he postdoced in Oklahoma, in New York, and then he worked for the Forest Service. About 8 years ago, he came to work for UW-Madison and the University of Wisconsin Sea Grant. Tonight, he's going to talk with us about sustainable commercial fisheries in the Great Lakes. Would you please join me in welcoming Titus Seilheimer to Wednesday Night at the Lab?
All right, thank you, Tom. So I'm going to take you on a voyage today through the world of sustainable seafood and combine some history of the Great Lakes fishery with some applied research that I've been involved with. First up, I want to talk a bit about what Sea Grant is. So I work for Wisconsin Sea Grant, and that is one of 34 Sea Grant programs throughout the United States. So all our coasts, the Atlantic, the Gulf, the Pacific coasts, but as well, the Great Lakes have been an important part of the Sea Grant program in its now over 50 years of existence. What we do at Sea Grant, this is our three-legged stool, and we really work in the areas of education, extension, and research. And I am fortunate in my job to be able to work in all three of those areas. So I might be working with a commercial fisher person one day, and then be on a beach talking to some middle schoolers the next, and then helping with research on the following day. Our focus areas, we have 4 focus areas, and these are sort of combined throughout the whole Sea Grant network. Whether you're in Alaska or Florida or here in Wisconsin, you're probably working in these 4 different areas. And in my job, I touch on a lot of these. Sustainable fisheries, that's definitely important. Healthy coastal ecosystems, you definitely need healthy ecosystems if you're going to have healthy fisheries. Workforce development is important, and resilient coastal communities. All of these are really linked with our Great Lakes fisheries. So I am, really fortunate to work in all 3 of these areas. Why we have that Great Lakes Sea Grant program. I always like to show off and kind of brag about how much coastline we have in the Great Lakes. So if you add up just the combined coastline in the Great Lakes on the US side, you got over 4,300 miles of coastline. And looking at this map, you can compare what that would be. That's the Atlantic plus the Gulf and about half of the Pacific there in the lower 48 states. So we are truly a coastal region. We are a coastal state here in Wisconsin. Over 800 miles of coastline on our Lake Michigan and our Lake Superior coast. So really a great resource, a great asset for us in the state. So that's sort of setting the stage of what I am and what we do here in Wisconsin. Next, we're going to dig into a bit of history, and it is sort of a long history or a short history, depending on how you look at it. And it's also an icy history. Icy because of the histories of glaciation. So the Laurentide ice sheet coming down from the north, as recently as 15 or 20,000 years ago, a lot of Wisconsin and really all of the Great Lakes covered in ice. And I think that is, the question I'm posing here, is that a long or a short history? Well, to us in our human lifespan, that 10,000 years ago is a long time ago. But if we were to travel to some of the African rift lakes in Lake Malawi, Lake Victoria, those are millions of years old, and some of the biodiversity in those African Rift Valley lakes thousands of species compared to the Great Lakes, which really are a sort of a very young system. And I think that is interesting to think about, and also important to remember that the Great Lakes, very recently geologically were covered in ice. And so the fish and the habitat in this area is fairly young. So the ice receded north and the lakes filled in, and since that time, different ecosystems have developed and changed over time. And that is, especially when we talk about fish, created diverse habitat for fish, and also diverse fish species are able to be present here. Now, I'm calling out fish species because I am a fish biologist, a fishery specialist, but certainly this is really, it's all the aquatic habitat. It's the aquatic species, the plants, the birds, the invertebrates. There's a lot of different things going on in the Great Lakes, but we'll focus mainly on fish today. So I'm going to take you through a few of these habitats. Coastal wetlands we will start with, and coastal wetlands are really at the interface of where the land meets the water. These tend to be they can be in river mouths, they can be in embayments, but they're along the shoreline, and they're very productive systems. They tend to warm up quickly. They produce a lot of different species, and they're important spawning and nursery habitat for a lot of different species. So, when we look throughout the Great Lakes, in general, some research has shown that about 3/4 of all Great Lakes fish species rely on coastal wetlands, either for part of their life cycle or for part of their food source, also relies on that. So, sort of these, you might overlook a marsh in your town or on a small river, but really an important habitat. They warm up quickly. They're great areas for young fish that might get larger, things like perch and bass and northern pike, to spawn in and grow up. So really important habitats there. I've spent a lot of years working in coastal wetlands in the Great Lakes, so just trying to spread some interest in those habitats. Another important Great Lakes habitat are those rivers and streams. So, I like to think of these as the highways or sort of the roadways that connect the Great Lakes with the Great Lakes watersheds. So these are pathways where fish can move up and down from the large lake up into the watersheds, up into the headwaters. And, they can use those for spawning habitat. They can carry their energy up into these streams. And one of those examples, things like spawning migration of different species. What we're looking at here are white suckers. And these are, one description I've heard is the sort of the gazelle or the wildebeests of the Great Lakes. So they're, these mass migrations that happen in spring. They're taking the energy because they're spending most of their adult lives out in the Great Lakes until the spring spawning comes, and they move in mass in these large groups upstreams, and they take that energy from the Great Lakes and they deposit it in the form of sometimes their corpses, because some of them will die, although most will return to the lake, but also their reproductive material, the eggs and sperm that they're depositing. That's going to be a food source and an energy source for these streams. So, not a necessarily something that you might think of if you're, 50 or 100 miles from the Great Lakes, but if those suckers can make their way upstream, they can really take advantage of that. Next, we kind of talked about the coastal wetlands. Those are really productive, but there's also a lot of the other parts of the Great Lakes where it's just beach habitats and kind of the close to shore areas of the lake. So, beaches are really one of the most accessible places for people to experience the Great Lakes. You can ride your bike to a beach, you can drive your car there, you can walk down, and you can really enjoy the Great Lake. And, sometimes you can even experience Great Lakes fisheries at those beach environments. Species like the rainbow smelt, which is a non-native fish in the Great Lakes, but when it comes into spawn in the spring, This is an image we're looking at from Minnesota, where it's a really big cultural event. People turn out every year. They go out there, fill up buckets with these little silvery fish, and then they take them home and enjoy them through the year. So that is definitely a time and a place that you can really get your hands onto these Great Lakes fish. And really the near shore too, even out to 30 meters or close to 100 feet. This is sort of the most accessible part of the lake, and it might be an area that people are out angling in or catching fish or just enjoying the lake. The sort of last part of the lake is the offshore region, and that's really when we get into the deep water. And I think one of the interesting things about spending time on the lakes and really even just being an aquatic scientist is that a lot of what we see in the lakes is sort of this mystery. Everything's happening underwater, and if you're on the surface, you kind of just see the surface. You don't see what's happening underneath. And the picture here, we're actually looking at over 100 feet depth, fairly clear water, and a school of lake whitefish being harvested here in a net. Lots of other different species using the offshore and lots of different interesting things happening. Species like the lake trout swimming around, sort of diverse habitat, big rocky reefs that other species might be using. So, really interesting habitats that, people might not have thought about very much, but really a lot happening out in the lakes. So that's sort of the habitat in general. Next, we're going to dig in a bit more specifically to the history of fish. I think important to remember, as long as people have been residing on the shores of the Great Lakes, and that's thousands of years now that the Great Lakes have been home to people, fish have always been a very important part of that. Really a concentrating factor and an important food source for the peoples who have lived here from thousands of years ago to today. We have archaeological evidence going back to 200 to 300 BCE, evidence that people have been here harvesting fish over that time. And that, for thousands of years now, some of those ways of harvesting fish have been very similar over time, using things like spears and gaffs, building weirs, and even hooks and lines. People have been building hooks for a long time and catching fish that way. The Great Lakes have been an important protein source for a long time, and one of the times that is most important for that, providing that protein source, is that spring spawning run for a lot of species. Things like walleye, sturgeon, suckers. Imagine you've kind of used up your stores through the winter, you don't have a lot of food left, and then spring arrives, and so do these very abundant fish species coming up streams and being very accessible to the point where you can just kind of reach into the water and grab them. So very important role of fish here. And from the Neville Museum in Green Bay, old, thousands of years old copper fish hook that was, because here in the Great Lakes region, especially areas like northern Wisconsin and the Upper Peninsula, with abundant sort of very available copper sitting on the surface, a metal that is, fairly easy to work, and, evidence of that is in this thousands of years old fish hook. Some evidence or, just sort of the story here of sort of the evolving technology used for different fish harvests. And this is a painting by Paul Kane from the 1800s showing, sort of a birch bark canoes, spearfishing going on, and an interesting, already the adoption of new technologies, because those baskets in this painting are actually made out of iron, which is, at this point something that these tribal folks, tribal members have traded with the sort of European settlers for these iron baskets and able to use this new technology to harvest in a traditional way. And certainly throughout Wisconsin, or in the northern parts of Wisconsin even today, spearfishing is still part of tribal spring food harvest. Another example here, just sort of the historic use of nets here to harvest an abundant food fish. And this is likely lake whitefish harvest in the St. Mary's River, which is just downstream of Lake Superior in the Sault Ste. Marie area. So we've got abundant fish in shallow water that are accessible with these nets. So long history of harvest and use of fish. As new sort of groups of people arrive into the Great Lakes, European origin people, colonists from the east coast of the US, or what is now the US, fish continues to be an important food source. It feeds sort of the expansion of the populations around the Great Lakes. It feeds, even trade with the East Coast continues on, and fish are sent back east to major population centers like New York and Boston. The Great Lakes, in addition to being this food source, are also an important transportation corridor. You can put a boat in Buffalo, New York, and you can travel without interruption to Milwaukee or to Chicago. And that is, especially back in the 1800s and earlier, an important transportation network. This is before there are railroads, before there are good roads. Water is a way to move through the system. And people using traditional technologies as well as importing fishing technologies into the Great Lakes region help harvest that fish. James Milner, who produced a report in 1872 on the fisheries of the Great Lakes, really outlined what was happening sort of early on. And there's a sort of an evolution happening here in the harvest of these fish. So we have, starting out, harvest of the more accessible fish close to shore using beach seines. And seines, we're basically talking about a large net. You can walk it out from shore, encircle the fish, pull the net in on both sides, and then just take those fish right onto shore. And that's a dominant fishery in the Great Lakes early on because the fish are accessible, and it does not take a lot of effort to get those fish. You don't really need a lot of boats. You don't have to go offshore. But as those really accessible nearshore fish decline, then there needs to be a shift to do new resources. And then the fishery shifts more and more offshore to things like pound nets or pond nets, as they're sort of locally known in my area, as well as gill nets, which are a long-standing traditional gear, but their use, as a fairly inexpensive net type that can be fished in many different places for many different species, are useful. And so that pushes the fishing effort more and more offshore to different species, different resources, different areas. There's a lot of heritage in the Great Lakes and a lot of, I think, interesting stories of how these fisheries transitioned and changed over time. One example, this is a picture here of the Great Lakes, a Great Lakes National Park, Isle Royal, out in Lake Superior, which is now one of the sort of least visited parks in the lower 48 states, but historically it had a lot of fishing families and sort of fishing communities that were housed there. So now we might go there to see moose and wolves, but historically people staged from this island and fished the really bountiful and cold waters of Lake Superior. Our fisheries will evolve, starting out early on. We talked about seines, so people were fishing from shore. As they moved offshore, sailing was how people moved around in the lake, and sail power was sort of the way people got out to their nets. And the picture here of a boat, this is actually called a Mackinaw boat, and it was sort of the workhorse fishing boat early on. And so lots of these little fishing towns, fishing ports would be full of these Mackinaw style boats. So it's a small boat, but it's very maneuverable, and it can be run by a small crew. And I think early on, especially, it's a hard work. Commercial fishing continues to be hard work, but early on, everything's done by hand, and that's going to limit sort of the depths you can fish at, and how much net you can set if you have to pull it in by hand. So, interesting sort of stories and progressions of different technology over time. And really the adoption and evolution of these fisheries really changes how fish are captured over time. So, some of the early evolution here, we move from that sail power fishing into things like steam engines, into gas engines, diesel engines of today. And that allows for sort of better boats, more seaworthy boats that have a larger range, that can work in sort of all seasons, and provide better protection for those folks in the boats. Economic importance, I think, also something interesting and important to think about. It's not just the economic value of the fish that are harvested. There's really historically a much greater role that these fisheries have in these coastal communities. Things like boat building, where back in the 1800s, a boat building company might have been started to build commercial fishing boats. And then, some of these companies still exist today, and they're building yachts. They're building other types of boats. Net companies, the Caron Net Company in Two Rivers, Wisconsin, started out building fishing nets for these commercial fishing industry. And today they're building nets for gymnasiums. A few years ago, the nets in the NCAA basketball tournament were built by Caron Net Company. So they're still in business, but they've shifted over time as the fishery has changed into different areas. Kahlenberg, a Two Rivers, another Two Rivers company, building these, starting out building engines for these commercial fishing boats. They're still in business today. They don't build engines. They actually build horns. So if you're ever honked at by an aircraft carrier, A, you're probably in trouble. B, it might be a Kahlenberg horn. And the same if you're at a hockey game and someone scores a goal. A lot of those are Kahlenbergs as well. So, that's sort of the broad history. Now I want to really focus in on the actual fish species history and how that has changed over time. So, this is looking at sort of lake-wide, Lake Michigan. How has that harvest changed over time? If you look at this at first, you could say, okay, it was high early on the left side, and it's declined through time. We're going to revisit that and whether or not that's true. But what we do see is some shifts in different species. So early on in this time series, back to the 1870s, lake whitefish, the purple bar here, the most important and most valuable commercial fish coming out of the lakes. Then there's a shift to the Cisco, or also known as the lake herring, and the other deep water Ciscos. We see through time there's sort of this ongoing importance of lake trout decline, and really the fishery closes. And I'm going to talk a bit more about what happened to the lake trout coming up, but really no more lake trout left at that point. And then we see an increasing shift to the bloater chub, which people might know as smoked chubs if they've ever had those. And then the resurgence of the importance of lake whitefish in Lake Michigan. And then we get to today, and really lots of importance of lake whitefish, but also I have the recreational fishery, because that is a piece of this fishery that the fish are being harvested by different people for different reasons, but the scale of that recreational harvest is much different than it would have been historically. So I think if we were to include that recreational harvest in this graph, it wouldn't look like quite a decline. But here's that, what if we start talking about alewives though? So the alewife is a non-native fish, came into the Great Lakes from the North Atlantic, where it's a native range, probably through the canals that we built to move between the lakes and into the lakes. And there's sort of an interesting relationship here. We have sea lamprey, another North Atlantic species, invading the Great Lakes. And what sea lamprey do, they are parasitic. They attach to fish, they bore a hole in their side, and they feed on their blood and fluids. We call them the vampires of the Great Lakes. And really, in the early 20th century, sea lamprey caused a lot of damage throughout the Great Lakes to many of our fisheries. Probably on the top of that impact list is the lake trout, and we've got a lake trout here. And if you think about here, where are we at? We're sort of the mid 20th century. Lake trout, their habitat has been damaged. There's a lot of pollution happening. There's sort of unregulated fishing, maybe unsustainable fishing happening for lake trout. Sea lamprey come in, and one of the numbers we use is that a single adult sea lamprey will kill about 40 pounds of fish to get to its adult stage. And so that's a big impact to fish like lake trout, and sea lamprey really seem to prefer lake trout. So by the 1950s, we actually have eliminated, there are really no lake trout left in Lake Michigan, and that opens the door for the alewives to sort of explode in population. At the same time, the fishery is sort of also depressed the populations of things like those deep water ciscos, the chubs, and so for an alewife to come in, there are no predators, few predators for them, and not much competition. Their population explodes, and at their sort of peak alewife numbers, the estimate is 90% of all the fish biomass. If we put all the fish on a scale in Lake Michigan, 90% of those would be alewives. So not a balanced fishery. This is a non-native fish species to the Great Lakes, and not a very healthy system. And rafts of dead alewives are washing onto shore. That's bad news for everybody, I think. And where we end up with that, we actually sort of two prongs, and I'll talk about those next. One of those is dealing with them with commercial fishing, and also with on the recreational side and stocking salmon. So, at this point, there aren't a lot of other commercial fishery species to harvest, but commercial fishers are able to really harvest a lot of alewives. They're very abundant, fairly easy to catch at some times of year. Sort of the trade-off, though, is that they're a low-value fish. You can harvest a lot of them, but you might be getting 1 or 2 cents a pound because they're not a food fish. They are being used in things like pet food for fertilizer. So, not a great species to have for your commercial harvest, but at least you can harvest them. And bottom trawling is one effective way to harvest them, and that is going to become important when I start talking about some of my applied research that I've done. So, same graph, I've added the alewife harvest. So that sort of picture of decline of harvest is not here anymore, because I've added this sort of non-food fish species, and we actually see higher harvests during those alewife harvest years than we did at the sort of peak of the Lake Michigan fishery, up to say 40 or 50 million pounds of alewife coming out of the lake. So, not a dead lake, but certainly not a fishery that you can really enjoy if you're thinking Friday night fish fries. And this alewife harvest sort of declines over time, and by the 90s, the alewife harvest is closed, and this is sort of a reflection of the changing food web, and reserving those alewives for things like the stocked fish to feed on. And so that is the other sort of side of the coin here. We're back to the mid 20th century, abundant trout or abundant alewife, that's the food, abundant prey in the lakes. And so the state of Michigan says, okay, what can we do with this? There's lots of food there. Let's create a sport fishery. Our sport fishery isn't in great shape. What species can we look at? And so Howard Tanner, the head of the fisheries division at that point in Michigan, sort of puts together a plan, working with his folks, to look at different species, looking at salmon, looking at striped bass. What would work well in the Great Lakes? What would be a good sport fish that would also take advantage of this abundant food? And so they first settle on coho salmon and stock those in 1966. Coho salmon are native to the Pacific Northwest up into Alaska. They start with those. Very quickly, they sort of shift more emphasis to Chinook salmon, and then really all the Lake Michigan states follow suit. And they start stocking these Pacific salmon, as well as rainbow trout, the sea run, ocean run form of rainbow trout, the steelhead, brown trout as well, and create what is now estimated to be a $7 billion fishery. Really a destination for people going out and catching big fish. And the $7 billion number here is really looking at all the Great Lakes, but Lake Michigan has a really big piece of that. So what does today's fishery look like? And I want to shift back to kind of our current status of our commercial fishery. And again, when we're thinking commercial fishery, we are thinking fish that are harvested from the wild that can then be sold. And the sort of state of our commercial fisheries here in Wisconsin and Lake Michigan are really a state of change and sort of a large scale impact from some of these invasive species. Things like quagga mussels have really changed the functioning of our Lake Michigan food web and our Great Lakes food webs. Other species, the alewife, the sea lamprey, rainbow smelt, and other invasive species, round gobies as well. Really big impacts that have really changed the lake. Where we're at here in Wisconsin, when we look at commercial fisheries, we think lake whitefish. That is sort of our main fishery these days. Even if we look Great Lakes wide, here we go, lake whitefish, sort of, at least in 2013, poundage-wise, highest harvest, as well as highest value here. Although, an interesting caveat, if we look at the next sort of 5 species, we're actually looking at the fishery of Lake Erie, where things like walleye and perch are being harvested, compared to the lake whitefish, which is really the main species of Lake Superior, Lake Michigan, and Lake Huron. So it sort of takes 3 of the other northern Great Lakes to equal the harvest of Lake Erie. And the reason why that is happening, Lake Erie is shallower, it's more productive, things grow faster. The perch and walleye themselves can be harvested at an earlier age, they grow faster. So that is just sort of where we expect to be for Great Lakes harvest. We can kind of zoom into Wisconsin's Lake Michigan harvest, and here it is over 90% of our commercial harvest is lake whitefish. There's still some harvest happening with yellow perch that is coming out of Green Bay. There's some of those bloater chubs being harvested, but a pretty small percentage. And if we turn back the clock to earlier, 30 or 40 years ago, we would have seen a lot more perch harvest. We would have seen a lot more chub harvest as well. And then we have the burbot up there, just sort of a favorite of mine. It's a member of the freshwater cod, or it's a freshwater member of the cod family, the only one. And if you ever get your hands on a burbot, they are quite tasty. We can go north to Lake Superior, and we see a little more balanced fishery up here. We see the Cisco or lake herring. In terms of pounds, a little more than half. Whitefish there, an important species. There's also the Ciscoette or fat lake trout, and then a mix of other species being harvested from Wisconsin waters of Lake Superior, including chubs. The Cisco harvest here, though, is really focused on the egg take. So they're harvesting those in November and December. And value-wise, there's actually about 46% of the value for this total Lake Superior, Wisconsin fishery is in the lake whitefish. So those are our fish species. How do we get them out of the lake? So I'm going to run through sort of our current harvest methods that are in use today. We'll start out with the gill net, and that has been used in the Great Lakes for thousands of years. Gill nets are, globally sort of an early developed type of fish harvest throughout the world. Basically, what you're using here is a net set in the water. The fish swim into it, and then they get entangled. It's called an entanglement gear. The materials used have evolved through time. Right now, the commercial gill nets are monofilament. So if you think, basically it's a mesh of fishing line, if you can imagine that. And then you can set at different depths. You can set at different places in the water column. You can see a bottom set in the picture, but you might float that closer to the surface to catch other species. And then the size of the mesh, the gaps, are going to determine how big a fish will be caught. So a larger mesh will catch a larger fish. So there is, it's not a totally indiscriminate fishing gear type. You can set it in specific places to catch, specific fish. In the Great Lakes fishing tugs, I think, are sort of a unique and iconic type of fishing net that we see throughout the Great Lakes. This is an enclosed boat. It allows for these fishers to be out in many types of weather throughout the year. They might be fishing in, November or December for Cisco, like these boats up in Cornucopia, Wisconsin at Halverson's. This is a peek inside on the table here, processing chubs. You can see in the lower right, sort of that round shaped object. That is actually the net lifter, which is a hydraulic lifter. It sort of spins around and helps pull the net out. And that's, one of the uses of technology that we see today. So we're not, pulling nets up by hand anymore. We're using these types of technologies. And then the final product here, some smoked chubs. And, for a lot of these Great Lakes commercial fishers, their markets might be local, places like restaurants, but a lot of them will also do these value-added products like smoking fish. That adds to sort of the life of a fresh caught fish. You've got several weeks there where you can sell it, and adds value more than just a simple raw fish. So next we move on to trap nets. These are called live entrapment gear. And so what we're seeing is with a trap net, it's a large net set on the bottom. You've got the pot on the left side, and that's where the fish sort of get trapped. They swim around in there. They're okay. They're alive. So it allows the fishers to pull the nets up and actually sort through those fish and throw things back live. They're set perpendicular to shore, and that sort of center net is called the lead, and that will stretch sometimes up to 1,000 feet towards shore. And basically a whitefish is going to swim along parallel to shore, runs into that lead, and its response to that obstruction is to go deep. And so it follows the lead into the heart of that net, and eventually into the pot. And there's sort of a minnow trap style funnel where they can swim into the pot, but they can't swim out. You need a specialized boat to pull these up. So unlike the fish tugs, this has a very small pilot house up in front just for driving the boat, and a big open back deck. And why it's open is you're going to pull that pot over the back of the net and then concentrate the fish in one side and then dip them out, sort them out. You can actually see a lake trout right in that box that they're sorting. That lake trout is not a legal commercial species in Lake Michigan for our Wisconsin fishers, so they can throw that back in. It can grow up to be a larger fish, and maybe some angler will catch it down the road. And just a look here of a couple boxes full of freshly harvested whitefish. Final gear type is the trawl, and in general, trawls are not that widespread in use in the Great Lakes. You might see them out in Lake Erie on the Canadian side, harvesting rainbow smelt. You might see them in the Michigan side of Green Bay harvesting whitefish. And we have a couple trawlers here in Wisconsin that are, have harvested alewives, they've harvested smelt, and now they're harvesting whitefish, which is what I'll talk about coming up. This is a trawler here, the Peter Paul. A peek in the inside, bringing the net in to the back, and some of the sorted whitefish that are being harvested. So 3 different gear types, and that is really an overview of the fishery. So what I'm going to do now is dig into some applied research that I'm able to conduct and work on, cooperative research with natural resource agencies, with commercial fishers, and Wisconsin Sea Grant to answer some applied problems and try to solve those in ways that can kind of help lots of different folks using Lake Michigan. So we're going to talk about trap net fouling. And so that is sort of the fouling of these commercial nets by things like algae. and also the risk of angler entanglement in these nets, because they are large. They might be hard to identify if you're out there on the water. On the fouling side for these nets, I think I've mentioned zebra and quagga mussels before, and these are non-native mussels that were brought into the Great Lakes in the ballast water of ships. They are small, but they are able to filter a lot of water. And our sort of current status of quagga mussels in Lake Michigan right now, there are trillions of mussels. Each one is filtering a lot of water all the time. They're eating the algae, and that has impacts on lots of different species. The little crustaceans, the zooplankton, have less food. There's less of those. That means less food for fish. And directly for things like the algae that we actually see around these mussels in the picture, that is Cladophora, which is a native algae, and it actually is able to take advantage of what the mussels have done to the lake. So here close to shore, we have clear water in Lake Michigan, and that means that light can go deeper, and that means that this Cladophora can actually grow deeper in the lake in higher abundances. And what Cladophora does, it grows attached to the bottom. As it gets really long, it kind of sloughs off, and then that sloughed off algae will float around, and if there's a gill net or a trap net out there, it will foul that net, make it kind of weight down closer to the bottom. It's not going to fish efficiently, and if you're a commercial fisher, it's going to make your job a lot harder. It might require you to go out there, several times a week to clean the algae off these nets. So this is a sort of an example of a native species. The Cladophora is native, but it's becoming a nuisance just because it's more abundant than it has been in the past. And another thing that the quagga mussels do is they actually bring a lot of nutrients down to the bottom, and that's where the Cladophora is growing. Even correctly set nets, correctly set commercial nets are a potential angler entanglement risk. You can see on the fish finder in the circle there, that is actually the lead of a trap net, and in 60 feet of water, it's coming up off the bottom about 25 feet. So that it's a pretty substantial size net, and if you're out on the water, this is what you might see: a single buoy with a flag on it. And that, if you don't know what the buoys mean, if you don't know why they're there, and you're fishing along with some fishing gear set really deep, you've got spoons or flies, you've got a cannonball to keep the gear fishing at a deeper depth, that can get entangled in these gear types. So one of the things that we have done over the years at Wisconsin Sea Grant is produce this trap net map, trap net pamphlet, to kind of describe what these nets are. So we're showing you the view underwater and what the different buoys mean. So we've got different colored flags, different numbers of flags, and they're all telling you different things. So if you want to avoid this trap net, just stay to the deep side of that black flagged buoy, because that is the deepest point of that net with the anchor there. And so these have been really popular over the years in the Manitowoc and Two Rivers area to keep people informed of where these nets are. And a second part is, sort of the ongoing cooperation with the commercial fishery is sharing the locations of their nets. And this was on that other side of the brochure. We would actually update these through the summer and provide the locations of the nets so people would know where they're at and be aware of the areas that they would have to be a little more mindful of these commercial nets. Over the years, we put out thousands of these, both online as well as paper copies at bait shops and boat landings in the area. So quite a bit of effort, but I think has really helped to improve communication with anglers, as well as help out with reducing entanglement. So that's sort of the state of where we're at. Fouling is impacting the commercial fishery, and entanglement is a risk for the anglers. So what we went about doing was trying to reduce that conflict through an alternate use of fishing gear. So instead of trap nets, we looked at partnering up with Suzy Q Fish Company, as well as the Wisconsin DNR, to produce a cooperative agreement that would allow for Suzy Q Fish Company to use their sort of existing fishing gear. So they are set up, they have the experience to bottom trawl for things like smelt, but they also have existing quota in lake whitefish. So these are fish they can harvest and have been harvesting with trap nets, but with fouling being an issue and entanglement being a risk, what could we do? What would be the sort of use of trawling for whitefish? So we kind of all got together. I worked on a study plan to help put together a study plan to look at trawling. And this is just a look in the back of the boat. That's a trawl rolled up on a drum there, ready to be set. And we came up with some research questions. So with a lake whitefish trawl fishery, what would be the bycatch associated with that? And what were some factors? Things like season, things like depth. What would be the species and the numbers? Those were the questions we wanted to answer, which would help the Wisconsin Department of Natural Resources make some management decisions. So we went out into the fishers we worked with are based in Two Rivers. The sort of dark black box here is an area within the DNR's administrative code where trawling was allowed. So we kind of stuck within that allowed trawling area and focused on lake whitefish harvest. So we went out and, long story short, before I show all the graphs and the figures, bottom trawling was an efficient method of harvesting lake whitefish. I think that is our first conclusion. Looking at some numbers, just an average, we can see sort of this is over the year from January through December. One thing to note is that in the month of November, the commercial lake whitefish season is closed. That is why you will not see an 11 along that bottom axis. Typically from say January through July, pretty consistent daily harvest here on average. Although worth noting that there are a lot of different factors determining when and how much harvest is going to happen. And that could be market factors. If they only need a certain amount of fish, they're only going to harvest that much fish. You can just leave the fish in the lake and catch them a different day rather than catching them all at once and then trying to store them. And pretty typically we saw this consistent harvest over the different periods. And just to note, I've got different bars here for different study periods. And the way you can think about those are over our study from 2015 to 2018. Each period is roughly a year to maybe a little more than a year during that time period. Catch rate is one way we can look at that harvest to sort of look at those numbers. And here we take sort of on an individual trawl drag, we can take the number of fish that were harvested on that drag because we counted everything, look at the distance of that trawl, and then standardize it because lots of factors will determine how long distance-wise a trawl might be. Weather or currents can really change. If you're going against a current, you're not going to move as far as if you're going with the current. So we standardize by distance so we can really make these comparable. And again, okay, we've got sort of from left to right, we're looking over monthly numbers from the beginning of the study through the end. And then each one of these panels is a different depth. So we start shallow on top and we move down to deeper. And I think what we're seeing in general is we see the most harvest up on top in waters shallower than 150 feet. We see some seasonal harvest in the sort of March through May at the 150 to 200 feet depth area. And then we see very little harvest in deeper areas. And that's, pretty consistent between years. What does the bycatch look like? That was an important question here for the Department of Natural Resources to make their decisions. And what we see overall, The primary bycatch are lake whitefish that are returned because they're either too small, there is a 17-inch minimum size, or they're lake trout. All the rest of our bycatch is on the bottom there, sort of a mix of species. Burbot being our distant third place, and the rest of those, really a handful of fish even encountered. I think we, over 3 or 4 years, we saw maybe 2 sturgeon. We can look at the bycatch in terms of absolute numbers. That's what in each one of these study periods, we've got our blue bar being lake trout, our red bar being returned lake whitefish. And you can look at those numbers just by bar height. And then the percent number on top of each one of those is a percent of the total catch encountered. So, in general, we're seeing about 2% bycatch overall. And, comparing that to a lot of different fish species, that's a pretty low bycatch. And the bars do get a bit taller, but it's worth noting that during these different periods, there was more sort of allowed quota that could be harvested, as well as sort of, they're not all the same number of months just because of different factors. So although those bars get a bit taller, percentage-wise, they're fairly similar. If we look at sort of bycatch by mile for lake trout, not much of a pattern here through the study. We don't see much. Pretty consistent month to month. If we look at the whitefish returned, sort of a similar pattern to the harvest, where there's this low period in August, September, and October, and higher harvest the other parts of the year. And what we're thinking happens there is that these are sort of schools of whitefish. They're mixed, sort of sublegal, and the non-marketable whitefish are sort of spending time together. And then when catch rate drops, that's when the fish are kind of staging, moving into shallow water and moving up the coast to spawn in places like Door County, northern Lake Michigan, northern Green Bay. And then on the bottom, we've got all our other species combined, and really not much for numbers of other species, and really no patterns as well. We also tagged a few of these lake trout to get an idea of their survival after they had been through the trawl and processed. And we had a close to 800 fish were tagged. About 7% of those have had returns from anglers. And I think the interesting thing, although a lot of those have been returned locally, we also see a lot of lake trout being returned on Michigan waters, the southern part of Lake Michigan. And we even had a lake trout that left the United States, went to the Canadian waters of Lake Huron, and was caught in a commercial net there. So lots of interesting things happening there. So how has this reduced angler entanglement risk? Well, if we look at sort of the study period here, before the study in 2013 and 2014, we had, in some years up to 19 trap nets out in the lake being fished by multiple people. And starting in 2015, as more of the whitefish quota was harvested in the trawl, by 2018 and really through the last few years, no trap nets have been set in this area. So one thing I can say for certain is a trap net on the shore, on the dock, is not going to entangle recreational gear. So where we came out with this, the DNR was able to take this data, take the report, and make a new rule that would allow trawling for a 5-year period, that took information from our study and basically closed the trawling season from September through November, just because there was lower catch during those months, and also continued our video monitoring system. This is something we worked on through 2016 through 2018, probably one of the few video monitored commercial fisheries in the Great Lakes, if the only video monitoring system. It's more commonly used in the ocean systems. Where are we at today? Well, we've moved our efforts, partnered with some new commercial fishers, partnered up with UW Green Bay and Patrick Forsyth, one of the professors there. We've hired a grad student who's out looking at southern Green Bay, looking at bycatch and catch for the lake whitefish fishery there, for both trap nets and gill nets, with an eye on a similar type of applied research, answering these questions about catch, about bycatch, and helping to inform management decisions. So as I wrap things up, I want to just put in a quick mention of one of our long-running programs here at Wisconsin Sea Grant called Eat Wisconsin Fish, which we started back in 2013. EatWisconsinFish.org is our website. And what we've done is we want to highlight Wisconsin's both wild-caught and farm-raised fish. We've got both of them in the state, and check it out. We can direct you, help you find local fish. We've got great recipes. We've got some great cooking videos for some salmon and trout recipes that you can follow along. We've got information on the fisheries, on the fishers, on the farms. So lots of great fish options for us here in Wisconsin. And with that, I'd just like to thank everybody, and thanks for watching. And I hope you've learned a few things about our Great Lakes and our Great Lakes fisheries. Thanks.